to talk about linear equations into variables. Now, oftentimes in this class, when I start talking about linear equations, somebody shouts out y is equal to mx plus b. Good. Fine, that's true. That is a linear equation. That's the equation of a line. But for our purposes, we're going to talk about something that's actually a little bit more general and more useful to us. So instead of looking at that, we're going to look at something called standard form. And these are going to be linear equations that look like ax plus by is equal to c. And here, x and y are variables. A, b, and c are constant numbers. So they'll be specified when we're talking about things. They might be 1, 2, and 3. I don't know. We'll find out. And we also want to say that a and b are not both 0. If they were both 0, we would get the equation 0 is equal to c, and that's not very interesting. So we're going to ignore that. All right. Now, we are interested in graphing linear equations, a linear equation, and they're called linear equations because the graphs are always lines. Okay, but what really is the graph algebraically? The graph is the set of points x comma y that satisfy the equation ax plus by is equal to c, i.e. the values that make it true. Okay. Now, what I often see people doing when they want to graph something like this, and that is a perfectly fine way of graphing this, they make a little table, and they write x, and they write y, and they start putting some values for x in, say -2, -1, 0, 1, 2. And then they plug these into the equation, and they figure out what y is supposed to be, and then they plot these points on an axis, dot, 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 and then they connect them, and happy birthday, there is your line. Well, that's a little bit too much work. In fact, we're going to find that there's something a little bit faster. But before even talking about the faster way, I'd like to say that plotting out 5 or 6 or 10 or 20 million points is more work than you really need to be doing. Why? Well, there's a fact that goes back to the Greeks. The Greeks, they sort of invented the systematic study of geometry, and what they told us was this: 2 points determine a line. If we want to draw a line, all we have to do is draw 2 points and then draw the line through them, and that is uniquely it. So all we need to do are find 2 points. Now, we could, again, just go back and maybe plug in -1 and -2 for x, and then find some y values and plot them. Well, it turns out that there's an easier, more systematic way of doing this, and this is using the intercepts. And this is where the line hits the x-axis or y-axis. So we have 2 kinds of intercepts. We have the x, let's say the y-intercept, because you're probably more familiar with this guy. Where this is where the line hits the y-axis. And then we also have the x-intercept, and this is where the line hits the x-axis. Okay. Now let's recall that I said if we're on the x-axis, then the y-coordinate is equal to 0, so the x-intercept has to look like x comma 0. Now similarly, the y-intercept has to look like 0 comma y, because the x-coordinate has to be 0. So in fact, this gives us a way of finding these intercepts. So to find the intercepts, we set y equal to 0 to and solve for x to find the x-intercept, and 2 we set x equal to 0 and solve for y to find the y-intercept. Fantastic. Okay, so let's do an example of this. Here is our coordinate plane, and why don't we graph the equation, let's say 5x plus 7y is equal to 35. So first we are going to find the x-intercept, and to find the x-intercept we set y equal to 0, and this gives us 5x plus 7y is equal to 35. We plug in 0, we get 5x plus 7 times 0 is equal to 35. That's 7 times 0, not 70. This just gives us 5x is equal to 35, and then we divide both sides by 5, and this gives us that x is equal to 7. And so that means that our x-intercept is the point 7, 0. So we go out 7 along the x-axis, and we don't have to move anywhere along the y-axis. This is our x-intercept 7, 0. Now to find the y-intercept, we're going to do more or less the same thing. Let's get rid of that work right there. Now to find the y-intercept, it's a little fatter than I want to write that. The y-intercept, we're going to set x equal to 0, and this gives us 5 times 0 plus 7y is equal to 35. And since 5 times 0 is 0, we just have 7y is equal to 35. We divide both sides by 7, and we get that y is equal to 5. So that means our y-intercept is we go up 5 for y, x is 0, we don't have to move left or right, so we got 0, 5 as our y-intercept. 2 points determine a line, so let's see how well I can draw a straight line between these two guys. Okay, that is our line right there. Fantastic, that's what our line looks like. Now in the book, BZB, those are our authors, BZB, Bartlett, Ziegler, and some other guy. They suggest that you should also go for something called a checkpoint, which is not a bad idea. A checkpoint is just any third point on the line. So a third point on the line, well, how can I find a third one? Let's just choose any x value which we don't see floating around over here. I've got x is 0, x is 7, so why don't I plug in, say, x is equal to, say, just for kicks, -7. Well, when I plug that in, I get 5 times -7 plus 7y is equal to 35, which then tells me that -35 plus 7y is equal to 35. I add 35 to both sides, which gives me 7y is equal to 70, and then 7y equal to 70. I divide both sides by 7, and that tells me that y is equal to 10. So that gives me the point -7, 10. This satisfies the equation. So here's -7, here's 10, that's this point up here. -7, 10 looks pretty good. It looks like we were going through that point, so fantastic. Even though this is a little bit sloppy, it looks pretty convincing that this is in fact what we were going for. Excellent. Why don't we just do one more example of this sort of thing? Let's plot the line I'm just trying to figure out what this is going to be. Let's plot the line 2x minus 3y is equal to 6. So again, we're going to look for the x-intercept, and we are going to look for the y-intercept. So first, to find the x-intercept, I set y equal to 0, and I get that 2x minus 3 times 0 is equal to 6, or 2x is equal to 6. I'm dividing both sides by 2. What that gives me is that x is equal to 3. So 1, 2, 3, there is my x-intercept. To find my y-intercept, I set x equal to 0, which gives me 2 times 0 minus 3 times y is equal to 6, or negative 3y is equal to 6. I divide both sides by negative 3, and I get that y is equal to 6 divided by negative 3. That's a positive divided by a negative. Positive divided by negative is negative. 6 divided by 3 is 2, so I get negative 2. There is my y-intercept. And now I connect these points, and this is what the line looks like. I come backwards. If I want to, I can plug in another point to do a checkpoint. So let's do a checkpoint. Let's say x be equal to, I don't know, 6. So that gives me that 2 times 6 minus 3y is equal to 6. Or that's 12 minus 3y is equal to 6. I subtract 12 from both sides, which gives me that negative 3y is equal to negative 6. Dividing both sides by negative 3, I get that y is equal to, well, negative 6 divided by negative 3. Negative divided by negative is positive. 6 divided by 3 is 2. So I get that y is equal to 2. That tells me that I'm at 6, 2. That's this point right here. That's pretty convincing to me that I drew the right line. Okay, finally I would like to talk about sort of some weird cases. And there are 3 weird cases. Weird case number 1 is when c is equal to 0, so that means that we're left with ax plus by is equal to 0. Now I would like us to notice something here. When we're looking for the intercepts, let's say we're looking for the x-intercept, so y is equal to 0, and this tells us that ax plus b times 0 is equal to 0. So ax is equal to 0, and we can divide by a, since a is non-zero, because not both a and b can be 0, so I get x is equal to 0 divided by a, which is equal to 0. So that means that the x-intercept is 0, 0, which is the origin. Well, the y-intercept then also has to be 0, 0. So this means that we are looking at a line that goes through the origin. To find the equation of such a line, I then need a checkpoint. I need to use a checkpoint here. So let's say I've got 2x plus y is equal to 0. I know that it goes through the origin by what I just said, but I need to use a checkpoint. So let's let x be, say, 5. And then I get 2 times 5 plus y is equal to 0, or 10 plus y is equal to 0. I subtract 10 from both sides, and I get that y is equal to negative 10. So I get the point 5, negative 10, which is down here, and this is going to be my line. So any line that has standard form ax plus by is equal to 0 will go through the origin. I can always plot the origin, but I need to do a checkpoint. In the next video, we will talk about the other 2 weird cases.